Hello, in this video I'm going to show you how to construct confidence interval for population mean. So first, let's say you have this information. You have a population of unknown mean. You don't know what the mean is. However, you know the variance. Variance is 221. And you have taken a sample of size 38, and you found that your sample mean is 35. So from this sample mean, you are trying to construct two limits in such a way that you are 95% sure that those two limits will include the population parameter mu. Although you don't know the exact value of mu, you are trying to estimate those two limits. Okay, how are you going to do that? Well, you have to know the distribution within which mu belongs. And to know that distribution, you can take help of z. We know x bar and z are related to each other by this equation. That means we can convert x bar to z. Okay, so let's look at the z distribution. We are looking for the upper limit and the lower limit of the z so that these two numbers will include 95% of the z distribution. So now if you look at the z distribution right here, you will see that this area that we are talking about is 95%, and that area, this white area plus that area, is 5%. So what is this z value? You can use Excel formula, norm SINV, and that number, that will give you the value. So let me just type it, equal to NORMSINV, and that is 0.05 divided by 2. Why divided by 2? Because half of 0.05 is here, half of 0.05 is there. Okay? So enter 1.96. So you can see this number is 1.96, and because of the symmetry of the distribution, that number must be positive 1.96, right? So these are called z cutoff points. So let me just make it 1.96. Okay, so we got it. So those are the z cutoff points. We know that 95% of the z value is between 1.96 and negative 1.96. So here I can write down, okay, this is positive 1.96, and that is negative 1.96. Okay, does it make sense? Okay, now we found out that the z belongs to these two numbers, and probability of that event is 0.95. Now we will replace this z with this formula. And once we do that, we are going to have this equation right here. We are going to have this. See, the only thing I have done is replace this z with this, because this is z now. Now the whole idea is to isolate mu by algebraic operation. So what you're going to do, you're going to multiply both sides. I mean, this whole thing, this inside, all the numbers inside the parentheses with sigma over square root of n. And once we do that, we are going to have a different expression altogether. So we are going to have this. You can see just rearranging the numbers. Now because we want mu in the center and we are looking for those two limits, so what we need to do, we have to remove x bar from this side by subtracting x bar from throughout this inequality. And if we do that, we are going to have another equation, which is another inequality rather, which is this. Okay, now we are almost there. We have to get rid of this negative sign. What we are going to do, we're going to multiply a negative 1 throughout this inequality. So what we are going to have, we are going to have this inequality. So now we can see, now we got whatever we were looking for. So we have this inequality set up, and we agree that this is equal to 0.95, and that is also equal to 0.95. So in other words, you know what are the values that will include the population parameter mu. Look at the left-hand side, x bar. Do you know x bar? Yes, you know x bar. Right here, 35. Do you know sigma? Yes, you can calculate sigma 221. And do you know your n? Yes, you know your n right there. So let's see what our upper limit is, what the UL is. Okay, so to compute UL, let's compute this part first. This is called error. So equal to 1.96 times SQRT 221 divided by 38. Remember, this is sigma, not sigma square, so you have to take the square root of that. And that is one area that many student makes mistake, okay? So, enter. Now I got the error. So only thing that I have to do to get the upper limit, UL is equal to, I have to add x bar with it. X bar is 35, so I can say equal to 35 plus this. This is my upper limit. And the lower limit is, I have to subtract lower limit x bar minus of this error, okay? So I have equal to x bar is 35 minus this error right there. So my confidence interval is 39.73 and 30.27. So I can write my confidence interval is parenthesis 30.27 and 39.73. In other words, I am 90, this is a 95% confidence interval. So that means I am 95% sure that the true population parameter mu in this case is included in these two numbers, 30.27 and 39.73. Okay, so practice this problem and then see if you can reproduce all the numbers that I did and follow the steps. And you will be fine if you just practice it several times, okay? Thank you very much. Bye.